Hey guys, it's Simon and welcome back to the Mystic Woods tutorial series with LibGDX and Kotlin. Long time no here, but I now have time to record another part to answer or to show 2 or 3 questions or comments that some of you had out there. One of the comments was if we could implement like a dialogue system or conversation system that you can, for example, talk to NPCs, and yeah, there will be then a dialogue that you can click through. And another thing was that someone asked if I could show something about testing and talk a little bit about testing, and that is also what we are going to do. So let me quickly show you what we are going to add to our little game. So what I did and what we are going to do, we will add another object or entity to our game. It will be this blue slime. I simply recycled it, but we will add some functionality that we can color it in a specific way or tint it. So as you see, the enemy is light blue and this NPC is dark blue. It does not move. And we can interact with it like we do it already with the chest. So when we hit it, then there's some special things, so we cannot move our character anymore. He also cannot attack anymore. He will be disarmed during that time while the dialogue is open. We will have some user interface where the dialogue is then showing up. So this will be the first page, let's say, of our dialogue. We will add some buttons that we can interact with. So to keep it simple, we will just add some text buttons that we can click there with the mouse. And we have 2 pages of the dialogue. So on the second page, when we click again, then we come back to the first page, and when we click OK, then we will close the dialog. So since I pressed the attack button again, it started attacking once more. But that's the tiny little feature that we are going to implement. Also, we are going to implement a DSL for the dialogue creation. You will see that in a moment. And we will also use the test-driven development approach, which I like a lot when defining some DSL, because then you simply write down first how you want to write your code, your DSL, and then you add the logic to it. And we also cover the testing part with that. So that's what we are going to do in this little part. So if you're interested, stay tuned. Also, one bad news that I want to share with you. So this will be the last video of this tutorial series because, first of all, as you have noticed, I don't have a lot of time anymore, unfortunately. So recording a video always takes me quite some time in between 2 parts. I think the last one was maybe 2 or 3 months ago. And then coming back to this code base and adding some features takes also a little bit of time again to read into it, what I have developed so far and how everything works in that specific game. And yeah, unfortunately, I don't have that much time anymore. But the more important point is that, in my opinion, I really showed you everything that you need to know to develop such small 2D games. Because as you will see in this part, most of the things that we are going to implement here, we already know it. It's just adjusting a little bit or reusing some of the things that we have already learned, some of the recipes. And that's why I think most of the additional features would be a little bit redundant to explain it to you. Of course, there would be special features like, for example, shaders or more advanced techniques, but I've never intended to cover that in that tutorial series. I made one video about shaders in one of my older tutorial series and some other special topics. Most likely, I will create another video which is not related to that specific game. I have a few ideas, but currently, most likely no time to record them. So just to be aware, this will be the last part of that series here. Okay, so let's start with our dialog DSL so that we can create and define dialogues in a convenient way. So to add, for example, the text that we have seen before, also then the different options that you can select per page of the dialogue and things like that. And as mentioned, we will use the test-driven development approach for that. What does that mean? That simply means that we are going to create some test cases first so that you also see how you could test your game. I will mention there a few things. And also I like that usually to create DSLs because I freely type in what I want to do. So how should the syntax look like for my DSL? And then I add the logic and the functions to it that it compiles. I like that approach a lot. I used that also in the Flex Entity Component system in version 2.0. And it's not always maybe a good idea, but in that specific case, I like to do that specific approach. So first of all, what we need to do, we need to locate our build Gradle file. I think I have never mentioned that, but in our core project here, there we have those normal dependencies, so API stuff, to add those dependencies to our core library of our game. And in Gradle, there is another type of method that you can use to add a dependency to your project, and that is called test implementation or test API. Not sure if there's test API, we'll need to look that up. In the GitHub project, it's implementation and test implementation. We will quickly check that if there's also test API. And the difference is simply that all the dependencies that are defined as an API or implementation, they will also be part of your game when you are going to bundle it into a jar file. So when you execute the Gradle build task, if I remember correctly, I think it's called like that. Let me quickly check. Yeah, so this build task or jar task, they will create this jar file for you of your game, and everything that is defined as an implementation or API dependency will be part of the jar file. And the difference is when you are using test implementation or maybe test API, then those are dependencies which are only relevant for your test source set. We will also see in a moment what that is, and they will not be part of the final jar of the game that you are building, which makes sense because when you are rolling out your game, you don't want to add additional space to your game with test classes and test code, which is not relevant to the final game. So test stuff should only be relevant for the development phase of your game, but they should not be part of the final result of your game. Okay, so as mentioned on the GitHub repository code, so there instead of API, we have implementation. And then I also use test implementation, as you can see it here, for the test dependencies. Here, for whatever reason, don't ask me why we used API. Maybe that is how it was created with the latest GDX liftoff version. The difference also, just that you know it, API means that this dependency is also exposed to other projects which would implement your game. So if another tool or another application of you would add this Mystic Woods core project as a dependency, then it would also have automatically those dependencies and classes available during the compilation phase and when you are developing your code. And when you use implementation, from what I know, instead of API, then this is more like an internal dependency, meaning that, for example, the Flex library is only available to the core project, but it will not automatically expose to other projects which would use the core project of Mystic Woods in that case. So that's the difference between API and implementation. And we will use here, as mentioned, test API. And there we are going to add some things that we are going to need for our test cases. So first of all, we are going to implement the JetBrains Kotlin test dependency. So what that dependency is doing is that it adds all these assertions that you maybe know from JUnit tests in Java or whatever language you are using, so that you can, for example, write something like assert true or assert false or assert not null, so that we can check for certain values in our test cases to validate them. And if it's true, or if everything is good, then the test will pass, and if something is not okay, then the test will simply fail. But if you have no experience with testing at all, then you will see in a moment what I mean with that. And I think for our DSL implementation, we actually would not need anything else. So that would be already sufficient. But I'm going to show you a couple of more things that you might need. And there, to explain it a little bit, so normally when we run a LibGDX game, we always have a context of OpenGL, which is important to, for example, render the different things. And I think also OpenAL most likely for the audio stuff, so to play some sound effects and music things and so on. And for some of your tests, you might need actually an OpenGL context. So for example, that your sprite patch can be created or initialized, that certain functionality that you call in LibGDX will work. And sometimes you don't really want a real context. So, for example, you want to test, let's say, an entity component system, and you want to start up your entire game, but you're not really interested that you want to draw something. So it should be just maybe make a call to world update once, iterate through the entire world and all its systems, and at the end you want to validate something that, for example, the entity moved from position A to position B. And in that specific test, or in those tests, you might not be really interested that you have a real OpenGL context, so you don't want to render anything. And to still run your tests so that nothing fails, if there would be some OpenGL calls in between, you can create a so-called headless version of a GDX game, which is simply a LibGDX game context, but the OpenGL context is more like a mock or a dummy implementation, and nothing is then really happening. So it's like a wrapper around your real game, let's say. That would be one way. Another way that I used in the GitHub project, and that is what I'm going to show you here, is that we are simply going to add the normal GDX dependencies to our test source set. I used that because I created some test screens as well, where I really wanted to render stuff and where I tried out how the user interface should look like, which was a lot faster and easier to debug certain things, because then I had just a user interface test screen, and there I could very quickly change the widgets and the layout and everything and refresh the application without all the additional overhead that comes with the normal game. So that's why I just added the normal GDX dependencies to that. And there we can, for example, go into our desktop backend. There we can take over those 3 lines here. So those are the ones which are important for GDX itself, so that the application can run. And then when we go back to our core project, let me close that and make that one bigger, then we can simply add it here below. And the thing that we are going to change is that instead of implementation, we change that to test implementation, because it should only be part of our test cases. Okay, and finally, what might also be important for you is that your test source set also has access to all the assets. So for example, if you want to test something with your tiled map or with some audio stuff, so with your audio files and so on, then you might want to have access also to the asset files. And for that, you can also add another test implementation dependency. And there we simply take a location to a directory. So we write here files, and then from our root project, we take one specific folder, which is called assets in our case. So that would be that folder here. And from that specific folder, we want to have the path to it. So this is what you will find on the, so instead of test API, we will have test implementation on the GitHub repository. And those are the lines and the explanations why we add that. And then there's one final thing that's not sure who needs to know about that, but you simply need to add that, that we say that our test engine, let's say, or the platform which we want to use for our testing is the JUnit platform. And the way we can specify that is that below here we have a test function or a test configuration, and there we say that it should use the JUnit platform as our testing platform, and that's it. Not sure what kind of other platforms there are available. I always used JUnits at work and also in my private project, so don't ask me what kind of other things are there available. And that would be it. So let's quickly refresh our Gradle project. It will then download like the Kotlin test library and so on, and I will be then back. Okay, it's already done. That was quite fast. Then I mentioned the testing source set. So what do I mean with that? Currently in our core project, we only have source main, so our main source set for the development stuff. And in addition, we can have a so-called testing source set. So when we create a new directory, you see here that IntelliJ already proposes a certain folder structure, which currently we don't have it available, but we can add, for example, a test Java, test Kotlin, and test resources, which is very similar to test main Kotlin and test main resources. So for our specific case, we just want to have a test Kotlin because we are working with Kotlin, and there we want to add now a specific test. Normally, you should have the same package structure that you have in your main application. So we are going to create here a new package, which we call comp GitHub quillraven blah, blah, blah. Then we will have an additional package, which we don't have yet available, but all our dialog logic or conversation logic, I use those both words for the same context. So sometimes I might say dialogue, sometimes I might say conversation, but I always mean the same. So all our dialog logic will end up in a dialog package. So let's add that here as well. And then we are going to create our first test class, which we will call simply a dialog test. Okay, and here we want to add now our first test. So there we use a simple annotation, which is called test, which comes from JUnit, and which simply tells then that the method that we are going to define is a test function. And when we run the tests of the test source set or of that specific class, then this specific function will be included for the testing. So that is what this annotation is doing. So let's simply call that function test dialog DSL. So I made a mistake. I made a Java class instead of a Kotlin class. I quickly fixed that. I just came from work before, and there most of the time I worked with Java, so I was a little bit confused. Please excuse me for that. Okay, and in this test method, we now want to define how the DSL should look like when we want to create a dialog. And the approach that I used, I will mention certain things then there. that you can adjust. But the way that I choose here is that I want to have a function which I call dialog, and every dialog should have an ID. So for example, in that case, let's call it test dialog. And then I want to configure that dialog. So I want to add pages to it, another page, or each page should have some options and things like that. So what I want to have in here, instead of calling it page, I call it node, because in my opinion, it's more like a tree structure that we are going to create. So we have a node. Every node has several branches. A branch would be an option like yes, no, or something else. And from a specific branch, you come to another node. So we have like a tree structure in there. A node, again, has a specific index. So here, the first one would be, for example, index 0. And it should also have some text. So for example, node 0 text. Here, this is already the first thing. So I went for a very simple approach. I simply hard-coded the text in the node itself. So it's always what I enter here, that is what's going to show up in the user interface. That is how we implement it. What you most likely want to have is that you pass in here more like an ID of your resource bundle. So when you add some internationalization, that you have your game in German and in English, then you want to pass in here just the ID of the message bundle, and then your dialog logic reads the text from this resource bundle, that you get the localized message into your user interface, so that you can switch between English and German. But to keep it simple, we just have the hard-coded text here without internationalization. So whatever we write here, that is the text of that node that is going to show up in the user interface. And then a node should have the possibility to define some options. So this would be the branches of our tree. So one option here would be, for example, next. And that option should go then to the next node. So we will define here another node with index 1, node 1 text. And that one maybe has two options. One option to go to the previous node and one option to, for example, end the dialog. So this is how it should roughly look like. And finally, we want to define what an option of a specific node is doing. So also here, we want to configure something. This is also the text that is then going to show up in the user interface. So the first page of our dialog would have the text node 0 txt, and there would be a button below with the text next. When we press it, we would go to the next node with ID 1. There, it will show up the text node 1 txt and two text buttons with the options previous and end. Previous should go back to the previous node, and end should simply end the dialog. Here, I made a very, I would say, generic approach and also a simple approach for our use case, that an option simply can define an action. And an action is nothing else than any function that you could call in the context of this DSL. So it could be something like, here we get in the dialog as the this argument. So we will have something like this at dialog, so from our function from above. And in the dialog, we have a functionality or a method which is called go to node. And there we want to go to the node 1. So we want to go to that node here below. With that approach here, we have a very generic way to implement actions. But I'm not sure if that is the best way to do it. Another approach would be that you define, for example, a sealed interface or sealed class and then certain implementations. So one implementation would be a go-to-node action. Another one would be an end dialog action. And then in those classes, you're going to implement the functionality. So you would have here then something like go-to-node action. And there you pass in, for example, 1. If you would implement it with sealed interface or classes and then certain implementations. But since I wasn't sure what kind of functionality I need then in the end for a dialog, it was simpler to just pass in a lambda argument, any function, and I can simply do then anything with the dialog that I want to do. That's why I went that approach with the function argument here. Okay, then here, that option would be very similar. So here we have our dialog again, but here we want to go to the node with the index 0. And the last one here, so that one should end the dialog. And here we would have something like this at dialog, and then something like, for example, end or end dialog, whatever we want to call it. So something like that, so that it then closes the dialog and the dialog is then finished. So that would be now the test-driven development approach. So meaning that we are defining the test first, and then we are implementing the logic. And I like that approach a lot for creating DSLs, because as you see here, I simply write the way I want to have the DSL look like. And now I simply add the functionality that piece of code where currently everything is red, that it then compiles. Okay, so let's go now to our core project and main source set again. And here we add a new package, as mentioned before, which is called Dialog. And there we want to add now our logic to create the dialog. So first of all, let me close that and zoom in a little bit. So when we go back to our test, let's split that to the right. I think that's the easiest way to show it. So first of all, we need a function here which is called dialog and which takes a string as an argument to make the first part here work. So we define a function which is called dialog, which has an ID which is of type string and which also has a configuration. And this configuration is running on a dialog object. So that's the this argument that we are going then to use in the actions below. And yeah, it's simply any configuration function. And this function in itself returns a dialog. So something like that. Currently, we are missing now our dialog class. So let's also create that one. So we create a dialog which has an ID as a string. And that's it for now. And here above, just to make it compile, we return a new dialog object, which takes in the ID. And then we are going to apply the configuration that we also pass in here. So this file is already compiling. And on the right side in our dialog test case, we now see here the red underline disappeared. So that one is compiling. And also this at dialog is already working. And step by step, we are now adding the different pieces that our DSL is working. Before we continue, I want to mention that also the approach that I'm using here is a more simplified approach and has the downside that inside the configuration blocks here, you have way more functions available that you should have to just configure the dialog. I show you that then at the end, but one way to solve that and one way that I used, for example, in the Flex Entity Component system is to distinguish between the real class that holds the data. So for example, in our case, our data class dialog and the configuration that comes with it. So for example, this node function, that's the only one in that case. So that node function, which is configuring the dialog, that should be, or the way I solved it is that I created then a separate class. So for example, a dialog configuration class. And up there, you use then a dialog configuration instead of the dialog itself so that you simplify or reduce the amount of functionality that you have available in this block of the dialog. I show you then when we add some functionality to the dialog and things like that, what I mean with that. But keep that in mind. One possible solution to reduce the amount of options that you have available in your DSL is simply by splitting it up between the configuration part and the real implementation of your class. Also, there are certain possibilities that you can add to your dialog, which I don't add here for simplicity reasons. But for example, a dialog could also have, instead of just a text, it can also contain an image that you show the image of the NPC in your dialog or anything else that you could imagine. So this is just a demonstration with simple text-based dialog, but of course you can enhance it whatever way you like. So let me quickly look up. Maybe I have a video on my YouTube channel with an old dialog that I used in another project that I never finished, just to show you what I mean. Okay, I found something. So that is a very old project from mine that I never finished. And here you see then in a moment, so the dialog that I implemented there is basically the same thing that we are going to implement here, but it has some additional functionality. So first of all, this dialog had a title or a name of the NPC that you are interacting with. Then it had an image of the NPC, and then the text that we also have in our example, and it also had options down here below. So what we just have the text and the options below, but here, for example, I added also a title and an image. And as mentioned, it's up to you how you want to define it. I think the solution that we are going to develop lets you easily enhance everything that you want to have in your game. Okay, so currently we are missing the node function here in our dialog that we can add something or some nodes to our dialog. So what we are missing, since this configuration runs in the context of a dialog, we are missing a function which is called node, which takes an ID, which is an integer, and which also takes the text of the node, which is of a type string, and then another configuration which takes in a node object and does something. So what we are missing here again is now our nodes data class, which is also a very simple one, which just has an ID of type integer and text of type string. And very similar to the dialog function here, we have here a node instance that we are going to create. And there we also are going to apply the configuration. Oh, and of course, this function needs to return a node itself. Okay, looks good. So now also the node part is going to compile here. What we are currently missing, so we are creating nodes, but we are not storing them in our dialog, which is not ideal because of course we need access to the node somehow in the future. So what we are going to do, we are going to add here some nodes, which is a mutable list of type node. So a mutable list of. And here, so we cannot directly apply the configuration and return. Here we want to do something. So first of all, we are going to configure our node. And then we take the nodes list that we defined before, and there we are going to add our nodes to it so that it's available and stored inside the dialog. So now we already are storing the nodes and can access them later on. Good, then the next thing would be in our node. So currently we are missing this option functionality or function. So we are going to define an option function which takes in a text which is of type string, and again a configuration which configures the option. Okay, and we are missing now this data class option which has a text. And here we are doing exactly the same thing. So we are creating a new option instance, we pass the text in it, and we apply the configuration. And let's return here also the option itself. Good, good. So now also that piece of code here is compiling, and the last thing would be now the action itself of a node, of an option, sorry. So since we cannot specify that at the beginning, because the action of an option is done via the configuration of the option, so we cannot use here a constant, so a value. We need to define here a variable, which we call action, and it's just an arbitrary function. And by default, it has no implementations, it's just an empty body. And with that, now this action is already compiling. And the final thing is now that we define those two functions in our dialog, so the goToNode and the endDialog implementation. So in our dialog above, we define a function which is called goToNode, which takes the node ID, which is of type integer. And then we want to set like the current nodes of the dialog, which currently we don't have that, but we need access to that then later on, that we know what is the current node of our dialog, that we can show the text and the options in the user interface for that. And yeah, so let's initialize that lazily. So current node of type node. And here we simply say then that the current node is equal to, from our nodes list, we get the first one or null if the ID is, for example, wrong and this node does not really exist. And there the ID must be equal to the node ID that we pass in. And if it's null, then we are going to throw an error. There is no node with ID, blah, blah, blah. Node ID in dialog, blah, blah, blah. Okay. So that's already the implementation of the goToNode function. Let's make that a little bit smaller. And the only thing that we are now missing is this endDialog function. Let's call it end, because we are already in the context of a dialog, so we don't need to mention that again. Let's just call it end. So let's make a new method, which is called end. And there we just set a flag. So for example, if this dialog is completed or not, here we set complete to true. And this is also just part of our data class, that we have it in the toString implementation of this class, that we see that directly when we debug something. And by default, the dialog is not complete. So complete is false. And here we set it to true. Since we have an end function, we also need a start function for our dialog. Again, here, if some things don't make sense to you, just adjust it according to your needs. This is just one way to do it. And I think it's, if you understand this concept, it's easy for you to adapt the functionality and do whatever you like in your game. So when we start a dialog, we set the complete to false, and also the current node will be simply the first node that we have in our list. So the first one that was defined. Perfect. And yeah, with all of that, we now have a working DSL already. So let me close that part here so that we have it big again. So this is our test case. Everything is now compiling, no compilation errors at all. And let me quickly go through our dialog logic once more. So we have our root function, let's say, which is the dialog function where you specify an ID of the dialog and then you're going to configure it. Then in our dialog object, you can add nodes with the node functions, and we have actions to go to a specific node and to end the dialog to complete it. And also we want to start it. So in case the dialog was completed and the user is triggering the same dialog again, so interacting with the same NPC once more, then we simply restart or start the dialog again if we reuse the same object instance. Then we have a node class where we can specify some options. Currently, we don't store these options, which is not correct. So we are missing here something. And then the option class itself, which simply is a text and has an action, which usually references then something up from the dialog. So let's fix the options. So we have, again, some options, which is a mutable list of option. And that is an empty mutable list at the beginning. And here, similar like we did it above, we can say here, we want to configure the option, and then options plus equals this, like we did it above with the dialog here. So we are storing here the options, and I think we could also make that private, right? Yes. And it can also be a value. So we never change the options instance. So that's good now. So that should be it. Okay, so coming back to our test once more. So currently we have just specified a dialog here, but we don't test anything with it. So we would just create it. Now we want to test it. So let's call that our test dialog. So we get an instance back of a dialog from our DSL functionality. And now we want to verify certain things. So first of all, let's start our dialog. And we also want to check now. So there should be an assert equals. So what we expect is that our first node is the current node of our dialog. So when we start the dialog, let's quickly go into this function. There we set this current node, and the current node is simply the first node that is specified in the configuration. So that is something that we could test. So we want to check if that node here is the current node of the dialog after we have started it. So for that, we need access to that node. So let's make here a variable of type node, and let's assign it here. And we also, in a moment, also need access to the second node. So let's also store that in here. Okay, so let's first try that one, if that is already working. So we simply start here this test. And amazing grace, it works. So let's test that. That is also something that I do. Let's make the test fail. So now we assume that the test should fail, just to be sure that we are testing correctly. That test should now fail. And we see that, so cross mark, then we get some information. We expect the node with ID 1 and this text, but we actually got the node with ID 0 and that text. So this test is already working. Then usually in a test as a best practice, you only want to test one specific thing, so one unit. But here, to keep it simple, we are testing multiple things here at once, which I think sometimes it's okay to do it like that. But sometimes, usually you should try to avoid it. But again, in some scenarios, for me, it makes sense. So what we are going to do, we want to go to our next node. And how do we do that? So currently we are missing a certain functionality. So in our dialog, we want to trigger a specific option. And the option simply has an index again. Not just a text. The reason why I used here an index, because in some games, I saw that the options, for whatever reason, have actually the same text. So maybe 2 times it's whatever text, so it's not unique. So that's why instead of using the text as an ID, I added an ID to the option, which currently I think we are also missing. But we want to have something like in our dialog, we want to trigger now the option of a specific node. And there we want to trigger the option 0. And this function is currently missing, so let's add that as a member of our dialog. So that would be the option ID. And to trigger an option, it's quite easy. So from our current node, we simply get the option with the specific ID. If that is not available, then we throw again an error that there is no option with ID, option ID in node, current node. So that would be a problem. So currently we don't have access to these options here. So we need an operator function which takes an option ID and returns an option. And there we simply return from our options the option with the index option ID. So that one actually could return null. Okay, so this one here is the option that we are going to get. And when we receive an option, then we are simply executing its action, whatever is defined there. So again, I think it's not so difficult. So to trigger an option in the dialog, we pass in an option ID and of the current node. So whatever node is currently active in our dialog, we get this specific option. And then we simply trigger the action that we have defined here, which could be the action of the dialog to go to another node. It could be the action to end the dialog or anything else. It could be an action to add some items to your character, whatever. Okay, so coming back here, when we trigger the first option, like here, then we want to go to the node with, up here. So when we click on the next option, then we want to go to the node with the ID 1. And then after triggering that, we would expect that our current node would be the second node. Okay, and also for debugging purposes, to have it complete, our option actually should have an index as well, or an ID. And the ID of an option is simply the size of the options list in our node. So the first option will have ID 0, the next one would have 1, 2, 3, and so on, which also, in my opinion, makes it easier than when debugging it, that you have all this information available for that class. Okay, so let's try that. That should hopefully also already work. And it does, so everything is green. So our go-to-node function is also working now. We could now also verify that option. So when we trigger now again option 1, we would go back to the node 0. And when we end, or when we choose option 1, then our dialog should be completed. So let's try that. So we trigger again the option 0. In that case, the option 1, which would be this end option. And now we want to verify there should be an as true. We expect that our dialog is completed. There we don't have the function for that yet, because complete, I think, is private. Yes, it is. So let's implement a method for that. So something simple like is complete, which is a Boolean, and that simply returns the complete information. Okay. So coming back here, we want to have something like this. So when we trigger the second option of our second node, then we expect that the dialog is completed. Let's see. And also that one is working. Amazing. For your information on the GitHub repository, I have some additional tests if you want to look into that in more detail. And also I added more safety to the DSL, because currently we could create dialogues without nodes, we could create nodes without options, and all of that is not really valid. So there I added some additional safety to it, but to save a little bit of time, because I think there is nothing special about those safety checks, we will leave it at that. So you have seen now how to create the DSL. One way to do it with the test-driven development. You have seen some tests and how it works, and I think that is great. So one thing that I did not show yet, which I mentioned a few times, is that in this configuration blocks, you have a lot of functionality available. So when we simply turn on the auto-completion, you see that we have here access to the current node, which should not be possible because it's an internal variable. Maybe we could solve that with making it private. We have access to the ID, which most likely does not make sense inside this dialog configuration. We have the functionality to call the start function here already, which we don't want to have in the configuration. Is complete also does not make sense. So as mentioned, we simply have here too much functionality available. And that is what I meant before. To solve that, you can simply split up your configuration logic, so the DSL part, and the real objects that hold the data, so the dialog objects in that way. So for example, the dialog configuration would just contain the method to, for example, create a node. That would be it. So splitting it up that way, you don't overwhelm the user with certain functionality which never can be, or which should not be accessed within that context. Another thing which is a Kotlin built-in stuff or built-in thing is when we are here inside a nested DSL object. So for example, here in the node, we could simply call the node function again, which maybe does not make sense because we don't want that you have some nested behavior here like that. And one way to solve that in Kotlin is the so-called, I think, DSL marker, if I'm not mistaken. So let's quickly introduce that. So there is some Kotlin built-in stuff which is called a DSL marker annotation, which is an annotation class. And let's call that, for example, dialog DSL marker. And now we can simply add this annotation to all our DSL classes. So for example, the dialog, then also the node, and finally the option. And with that in place, we get now, first of all, some compilation errors. Okay, so here, for whatever reason, it wants to have that we call the options now with this, most likely because the way it's now compiling the stuff in the background. Don't ask me about the details, so we just quickly fix that. And coming back to our test now, when we would be inside here of this node configuration, as you see, we don't have the node function now available anymore. So now the Kotlin compiler knows that those are DSL classes and that we don't want to nest them and so on. So it simply hides certain functionality for us, which is always a good thing, in my opinion, when you define the DSL. So you should keep the functionality inside those blocks to a minimum, that you really can only access the things which are important for the configuration part. Okay, with that, I would say that's the dialog part and so the dialog DSL part and the testing part of this video. So next, let's continue with the user interface. So there again, we use the approach that we always use. So we will create a dialog model and a dialog view. And again, to save some time, because there's nothing new to it, we won't implement the dialog view. I just show you the final code because there is nothing new that you can learn. But the dialog model, I think that one makes sense. So that one we are going to implement together. So first of all, let's close everything. And the first thing that we are going to do is to enhance our skin. Why, Simon? Because we don't have buttons yet in our skin available. So if we want to add options to our dialog, we cannot do that yet, so at least options that would be clickable by the user, that something gets triggered, like the trigger option function of our dialog. For that, we need buttons. And there are several buttons available in Scene2D. There is an image button, which is a button with an image, obviously. Then there are text buttons, which is a button that only contains some text. The button itself is also available, but is maybe an abstract class or interface. No, you can also just have a button as well. Not sure what that is exactly doing. And maybe there are some other buttons implementations as well, but we don't care. We want to have a text button in our scenario. So let's add some functions here and also clean up this function here, so the load skin function a little bit, to make it cleaner. So first of all, we need a new enumeration, of course. So let's make a new enum and call it buttons. Then we have here just one style for the time being, which is the text button. And again, we have a skin key, which is simply the name and the lowercase of the name. So everything like we already had it before. Nothing new here. Then we are going to clean up here this functionality here a lot. So first of all, let's split that up. So load skin and this font stuff here, that should be a separate method, which is called load skin fonts, for example. Okay, let me also zoom in a little bit. Then we have some label styles. Okay, all of that is actually label style. So let's also extract that and call that load skin label. Okay, I used the plural here, so let's call that load skin labels. And finally, we are going to implement a new method, which is called load skin buttons. That takes over the skin. So it's the same stuff as we have it here, but the difference is that it's called load skin buttons. In case you're wondering, the hotkey for that, at least for me on Windows, is Control Alt and M to extract a certain piece in the method to another method. You can remember it like that, M for method, so Control Alt M to extract a method. Makes sense, right? Good. Then, what do we want to do? So here, very simple. We want to create a text button skin that we call skin key. So from text button, the skin key, so from the enumeration that we created before. And there we don't need a lot. We simply need the font. And from our skin, we take the default font in that case. Not plus equal, it's just an equal sign here. And since we loaded the skins, the fonts before the buttons, we can already access it. And that's it. So with that small adaptation here in the skin file, we have now text button skins available and can use it in our interface. Good, then the next thing is that we are going to implement the model stuff. So with our user interface, we always have the split between the model and the view, and we want to use the same approach. So we go into our user interface model, and there we are going to create a new model that we are going to call dialog model. So the dialog model, as always, with all our models, it takes a stage, and it extends the property change source, and it is also an event listener of scene2d. So for that way, we need to implement the handle method, as always. And the model itself is also not that huge, so we have a dialog, which we initialize lazily when a certain event gets triggered. So that's the reference to our dialog object that we are going to create. And then our dialog has a text which should be displayed. So that would be the node text. And there we have our property notify from our property change source available. Then we have options, which is simply a list of a so-called dialog option model, which we are going to implement in a moment. So that's again the user interface wrapper for our option class in our dialog. To keep that separated in case the model gets different to the user interface, then yeah, we are more free and it's a cleaner architecture of our code base. And finally, we have a completed information, which by default is false. So our dialog is by default not completed. Then we have the constructor where we simply add our model as a listener. So all of that is already known. I think we did that, not sure, 2 or 3 times already. So there should be really nothing new. And finally, the important function would be here in the handle method, where we check what kind of event do we have. And if it is an entity dialog event, then we want to do something. And there we are setting our dialog to the dialog that we get passed in from the event. We are going to create this class in a moment. Then we are going to call a function here, which we call update text and options, which we call, first of all, here when a dialog event gets triggered, but we also want to update the text and the options when we switch to another node. So for example, when we call this dialog go to node function, then we also want to update the text and the options. And finally, if any other event is coming, we return false, and otherwise we return true because we are handling something. Okay, let's start with the update text and dialog options. Oh, that was wrong. Oh, God. We want to create just a normal function. Let's move it up there. So what we do here, first of all, completed gets set to the complete information of our dialog, because when, as mentioned, this function also gets called when we call the go to node option. And it could be that one of the options is simply completing the dialog, and then we don't need to update the text anymore because we can simply close then the user interface for the dialog. So if it's not completed, that's why we check it here. So if it's not completed, we want to update the text, which is simply the text from our current node. And the options is also simply the options. We don't have access to them at the moment because we made it private. Let's quickly change that to make the options public again for simplicity reasons. So here we want to have the options, but we want to map them to something else. So we want to map them to this dialog option model that we don't have yet, but we're going to have that in a moment. And there we pass in the index and the text. That makes more sense than in a moment when we implement the view. So basically, just to give you a little bit of a heads up, as we have seen in the introduction video, in the showcase, we have this dialog user interface, which shows the text and also the options. And the option itself will be this dialog option model in the user interface, which has the index and the text. The text to show in the user interface what is the name of the option, and the index to trigger then from our dialog this trigger option function with the correct index. So that's why we need both of this information. And that's it. So when we want to update the text and the options, we check, is the dialog complete? If it is not complete, we update those things. And if it is complete, then we don't need to do anything because dialog is done and we can simply close it. Okay, let's fix these compilation errors. So first of all, we need a new class, which is called dialog option model. And that one is pretty simple. So it's just a data class, and it has two informations. It has an index and it has the text of the option. That's already it. So dialog option model is done, and now that one here should compile perfectly. Then we need the entity dialog event. So there we go to our event file, and there we add a new entity dialog event, which takes in the dialog object itself. Make sure to import the correct one, so not the dialog from C to D. We want to have the dialog from our own implementation. Okay, so coming back to our dialog model, that should now also work and compile perfectly. Okay, so the only thing missing is, as mentioned, somehow we want to trigger the option of our dialog with this model. So there we're going to implement a new method, which we call trigger option, which takes in the option index, and that's everything that we need. So there we simply then call the trigger option of our dialog, and we also call this update text and options function. So that part here triggers then either the go to node function or the end dialog function, whatever we added here as an action for the option, and then the user interface gets updated here automatically because of our property change source. So that one we are going to see in a moment. What we are currently missing here, didn't we call it index? We call it just ID. So the option here is not an index, it's the ID. Okay. Good, so with that, the model would also be implemented. So the next thing would be the dialog view itself. So let's create here a new class. We call it dialog view. And here, as mentioned, because there is really nothing new to it, I will go through the codes in a second, but we are not going to implement that together. We save some time in the video because, yeah, again, there is nothing new for you to learn. So with the magic of post-production, we have our dialog view. So let me quickly go through you and guide you through the code. You can always find it on GitHub. So as always, our view takes in the model, which is our dialog model, and it simply has two things. So one, dialog text, which is a label, so that's the text of our dialog node, and it has a button area, which is the area below for the different options of a node. So then, as always, we fill the parent, we set the alpha to 0, that it's not always visible, because this view should only be visible when a dialog event gets triggered. Then some styling stuff with the background. Here we define the label of the dialog text. We make sure that the text is correctly wrapping, some padding as well. And we also have then the button area. Here, you see the comment also on GitHub. For me, it would have made sense to use a horizontal group because I wanted to have the buttons aligned horizontally. But again, Scene2D magic, I have no idea how it works. It simply screwed up my layout all the time. So in the end, I simply went with a normal table. That one worked. And there I added 2 text buttons. Would make more sense to have that dynamically. So in case you have more than one text button, more than one option, more than 2 options in your node, that you dynamically create the amount of text buttons. But in my example, I had at most 2 options and I simply hard coded it. But to be more flexible, I would create this amount of text buttons here dynamically. Okay, then fixed width and height, and finally the data binding. So when the text changes of our dialog model, then we update the label. If the completed information changes, then we simply hide the dialog. So we set the alpha value to 0, and we clear the children of the button area. And below here, so when the dialog options get updated, then we clear all the childs. So I did that already. Sorry, I forgot about that. So creating here 2 buttons, in my opinion, is maybe not necessary. You maybe can just create 1. Here we dynamically then create text buttons and add it to that table container that I have shown you before with an on-click event. So when we click on this button, then we want to trigger the trigger option function of our dialog model with the index of our option. So that's it. So nothing fancy, nothing new in my opinion. I think we know all of that already. And yeah, so we also have the Scene2D DSL, of course, to add then the dialog view to our game screen, which we are going to do now. So let's switch to our game screen. And there is an area exactly here where we add all these different views to our game. And for example, after the game view, we want to add a dialog view with a dialog model, and we pass in the game stage. Okay, so let's quickly test that. So for testing purposes, let's make the alpha value 1 here, and let's start our game and see if we can see the dialog user interface. And ta-da, we already see something. So the user interface is there, which is great, but it doesn't have any text yet. So maybe let's fake it and trigger a dialog event just to see if also that is correctly working. So let's go back to our game screen, and maybe here afterwards from our game stage, we fire an event, which is a game, how did we call it? Dialog something event. Entity dialog event, and there we pass in a dialog. And for example, let's use the dialog that we created in our test case before. So let's just copy and paste that over. We cannot store the nodes, of course, because we don't have the variables for that. We also don't need them, but we want to pass in here the test dialog. So let's see if that is also working. Okay, of course, we need to call the start method of our dialog. I just added that. Otherwise, you get an error that the current node is not initialized of the dialog. But doing that, also that is working. So we see this node 0 text from our test dialog. It just has one option. When we click on next, we get to the node 1 txt, so to the second node. With previous, we get back. And with end, we are simply closing the dialog. And there, that's great. You see already a problem with our current implementation. So now, for whatever reason, everything is black, and there seems to be a bug. And indeed, there is a bug, which we are going to fix now as well. The bug is occurring in our render system when we are playing around with colors and so on, that the color is not correctly restored. So what we need to do, so for example, here in our background layers, here we always want to say restore the color of our patch to the color white, which is the default one. And the same we want to do in the foreground. So before we render the map, we also want to restore the color to white, because it could be that in the user interface part here, so in the Scene2D user interface things, we are maybe setting a different color like black, or in our case, an alpha value of 0 when we close the dialog view. And this alpha value of 0 is then used for that batch rendering here below of our foreground layer. So that's why everything was dark. And to fix that, we correctly need to restore the color after we call the Scene2D user interface rendering stuff. So now the problem that we had before should be solved. So when we click next, and now when we end our dialog, you see that everything is still rendered. So that was a small bug that we had in our code base, and that one is solved now as well. Okay, so really great. We already have now our dialog logic. We have the dialog model and the view. We see that the view is already working. We can interact with the buttons and everything. Everything is really great. The only thing missing now is that we want to add an NPC, so this little blob. We want to color it and we want to interact with it, and then we are done. Okie dokie, so let's first of all close everything again. And as you know, whenever we want to do something fancy in our game, we want to add a component to add some logic to it. So let's create a new component, which is called a dialog component. A dialog component can be a data class, and it simply contains a dialog ID, which will be an enumeration. And by default, it shows to no dialog at all, so dialog none. And let's quickly create here an enumeration for our different dialogues that we are going to have in our game, and that we are going to configure also in a moment. So we have two dialogues. We have no dialog, which is the default, and we have then one specific dialog for this blob NPC that we are going to add. And of course, we want to have then a reference to the dialog itself, which per default is null in that case. So that dialog here gets then passed into our dialog event that we triggered before in our game screen manually. By the way, before I forget that, let's also remove this test stuff. So first of all, let's remove here this event firing from our game screen. And also in our dialog view, let's restore the alpha value to 0, because that is how it's correctly set up. Okay. So component is done. Then the next thing is... yeah, I think I heard all of you. It's the system, the dialog system. The dialog system. So there we are going to add now some logic. So first of all, we want to iterate over all entities which have a dialog component. Then we need access to certain components. So first of all, the dialog components. And we also need access to the move component, because we don't want that the character can move when he is interacting with the dialog. So we will root him that he cannot walk around while the dialog is opened. And we, of course, need access to our stage. Oh, I think here we did not use a specific qualifier, so we can simply pass in here the normal stage. That would be our game stage, if I'm not mistaken. And the system itself is, of course, an iterating system. And there we implement the onTick entity function. So as always, normally I implement some kind of caching so that I don't recreate the same objects again and again. So we are going to implement a dialog cache, which is a mutable map, where the key is simply the dialog ID of our enumeration, and the value is a dialog object itself. Okay, and then when we are iterating through such entities with a dialog component, we get the dialog component from the entity. Then we get the triggering entity, which is simply the... Did we not add that to the dialog component? Oh, I forgot that. We also want to have an entity here, which is actually triggering or interacting with an entity that has a dialog component. So we need that here as well. Let's add that. So what we simply need is an interact entity, which is any entity, but default it's null. So the logic is like this. Let me explain that. So there will be our blob entity, which has a dialog component, and as long as it does not have an interact entity set, nothing is happening, so it won't trigger an event. But when it has a triggering entity, so someone is interacting with our blob, then we want to fire the event and do certain things. So first of all, if the trigger entity is mentioned, so if it's null, if it's not set, then we simply return. So there we don't want to do anything. We don't want to fire an event. We don't need that at all. Then the next thing that we need is our dialog, which is the current dialog. And if the dialog is equal to null, that should actually be an error, because then the dialog component somehow was misconfigured. So no dialog defined. So that's not the cleanest way. of an error message, but you get the idea. So if you don't specify a dialog for a dialog component, then something is wrong. Okay, and finally, so if the dialog is completed, then we want to unroot our entity. So as mentioned, we are going to root it that our player cannot move anymore. So if it has a move component, then we set our root flag to false so that the entity can move again. Then we will also set the current dialog back to 0. And we will also set the interact entity to null, not to 0, to null, sorry. Okay, and if it is not completed, so here we also want to return then. So then we don't want to do anything. And if it's not completed, so let's think that through. So we have an entity which is triggering the dialog. Then, okay, this is wrong. Sorry, I had that wrong in my mind. So here we want to check. We just want to assign the current dialog of the component. If the dialog, we can work here with a question mark, I think. No, we cannot. So if the dialog is not null and it is completed, sorry, once more, we need to nest that. So like that. Sorry for the mistake. So it is like that. So the dialog initially, the current dialog will be null. An entity is now interacting with it, and we want to initialize now the dialog. So we want to get it from the cache via the dialog ID that we store in the component. So that was the logic. Forgot about that. So if we already initialize the dialog, that would be here. Then we just do nothing special because everything is running through the user interface. So we have the options there available, the user can click the different buttons and the system does not need to do anything. It just, when the dialog is completed, then we want to unroot the entity and we want to reset those temporary values to null, that another entity can interact again and another dialog can be created again or retrieved from the cache that we are going to fill in the moment. That's the logic. And if the dialog is null, so we did not get it yet, but an entity wants to interact with it or wants to see a dialog, then we are going to get the dialog. And there we pass in the dialog ID from our component. So now it makes sense. And also what we want to do here, we want to call the start method of our dialog, so to initialize it correctly. So that needs to be a variable first of all. Okay, and below that, we set the current dialog in the component to this dialog that we created or received from the cache. Then we are going to root the entity which is interacting. And we also want to fire our entity dialog event here, where we pass in the dialog that we created before. So now it makes sense again. Sorry for the confusion above, but now the memory is coming back. Okay, so what we want to do, we need a function which takes a dialog ID and which also returns a dialog object, so that the compile issue here is resolved. And this getDialog function is simply returning a dialog from our cache. So get or put, the key is the dialog ID. So either we already have it in the cache, and if we don't have it, then we are going to create a dialog. And there also, to save some time, I'm simply taking over the configuration from the GitHub repository. So that's it. So when our dialog ID is the blob dialog, then this is the dialog that you can find on the GitHub repository that I showed in the introduction video with this hello adventurer, blah, blah, blah. So that's the dialog that we are going to return and put inside the cache. And if we don't match any of the IDs here, then we are going to throw an error, because then we are interacting with an entity and its ID, its dialog ID is not matching any dialog object, so we are not configuring or creating any dialog for it, and then something is wrong, because then we are missing something in our game, and that's why we throw here an error. Good, and I think that was the important part. Let's see. We are missing here a closing bracket. Yep. Okay, so what we need to do when we have our system finished, we need to add it to our game screen. So for example, after the loot system, we can add our dialog system. And now we need to do some adaptation again with our spawn configuration and so on to support the NPC and everything. But also there, I think there is not a lot of new things, but just that you see it and as a practice, let's do it together. So first of all, let's switch to our spawn component. And there we have a spawn configuration, which now also allows the configuration of a dialog ID, which per default is none. So normal entities don't have a dialog. Then we need to go to our entity spawn system, of course. There, somewhere up here, so where we create all the entity stuff, for example, here after the physics component is available, we can say if the configuration contains a dialog which is not none, so a specific dialog is configured, then we are going to add a dialog component to our entity, and the dialog ID is equal to the dialog ID of the configuration. And finally, we also want to add, of course, an entity which contains a dialog. So let's copy and paste the slime. Let's call it now blob. That will be our NPC. It has a life scale of 0, so that it does not take damage or show any damage numbers, so we cannot really damage it. I think that's important here. And now we need to adjust our map to include this blob here. Let me see. I hope I have still tiled installed. So what I'm going to do, I just copy and paste this slime now here, move it below here, and it's not called slime, it's called blob. I think we have written it like that, right? Yes, so blob with capital B, blob with capital B. So that would be our NPC with which we can interact then. So the only thing missing currently is our attack, to update our attack system, so that like with the chest, that we can also interact with entities which have a dialog. So let's go to our attack system. And there we had some logic somewhere. Like here, so first of all, when it has life component, then it can take damage, but we set the life scaling to 0, so our blob does not take damage. And if the attacker is a player, if something has a loot component, he can interact with it. And similar now, we want to have here a logic like from our dialog component. So if an entity has a dialog component, then we are going to set the interact entity of the dialog component. So it works very, very similar with the loot component. The reason why I distinguished between it, because here we have this dialog ID and things like that, and in the loot component we did not have that. So also up here where we have the loot components, let's make here another mapper for the dialog component. And I think that should be it. So hopefully we can now already interact with our blob and see the dialog working. So here's our blob, which can actually move around and then does something very weird. We don't want that. He should not have an AI, of course. So our blob should not move around. He's missing, I think, certain functionality. Okay, so now nothing is crashing when we collide with him. Let's attack him. Damn it, something is not working. Let's see. So I forgot to specify the dialog ID here. Okay, another try. Ta-da! Great stuff. So now we have the dialog here. We can interact with it like we saw in the introduction video, and we can close it as well. Also, when I try to move around, I can actually move around. So that one we need to still fix because the player should be rooted when he's interacting with an NPC. Let's see. Okay, so I figured it out what the reason is for it, but it's way too hot in my room, and I think it doesn't matter really for this video, and don't know what I did different in the YouTube tutorial series than I did on the GitHub project. The reason is that we have this attack state for our player, and at the end of the state, it sets the root value again to false, which is overruling what we did in the dialog system. So that's why currently he can still move after the attack. I think it's working on GitHub if I remember correctly, but again, it doesn't really matter for this video. You can figure that out yourself. The important part is the dialog system and dialog component. The video is already quite long, but I still want to show you or introduce two nice features which I liked. The first one is that I wanted to tint the NPCs a little bit, so give them a different color. And one way to do that would be in style. There is a property which is called color. Let's call that color. And there we can set just a specific color. Let's make him, for example, red here. And now to support this property in our game, we just need to adjust the entity spawn system. So coming back to our code, let's go to the entity spawn system. So when we are going to add a spawn component here below, so this is when a map gets changed and we create all these different entities, then we are going to add here also, instead of just a type and a location, we also set here a color, which is from our map property, a color, and the default value is the color white, so no tinting at all. That would be it. Then, of course, we need to add this color to the spawn component. And by default, as mentioned, it would be color white. Let's import the correct GDX color. Okay, and the only thing that we then need to do is up there where we are creating the image component. So down there is already a property which is called color, and there we simply set it to the color from our spawn component. So let's see, I think that should be already it. So now our NPC should be a little bit tinted with a red color. And ta-da, we have that. So that is one easy way to add a little bit of flexibility to the color of your NPCs. Unfortunately, I did not find a way if you can somehow preview a tinting or set the color here directly on these objects. Would be great if you can see the result already in tiles. Maybe there's a way, let me know in the comments. But I just wanted to show you that is one way to add, in my opinion, a useful functionality very easily to our game. And the last thing that I wanted to add, and which maybe solves the problem with the routing, let's see, maybe that combination is the difference, is that I also wanted to disarm the player while he is in the dialogue so that he cannot attack again and again and again. And for that reason, we are going to create a new component. That's the final thing that we are going to do. Let's call that Disarm component. And it's just a class. It has no information. It's more like a flag on your entity that you know if it is disarmed or not. So first of all, in our attack system, that one we only want to trigger an update if an entity is not disarmed. So it should not have a disarm component. Okay. And the last thing is that in our dialog system, there we want to add and remove now the disarm component so that the player cannot attack anymore. So up here, so there we want to configure our entity, which triggers the dialog. And here we simply want our disarm components, and we want to remove it at the end of the dialog. And below here, there we want to add the entity. So we want to add a disarm component to it. And let's also get the mapper for it. And now let's try it. So, blob. So I cannot attack anymore. So maybe you hear me clicking. So we are now currently disarmed. And it looks like it is the combination. Can I now move again? Okay, yeah, funny. So it is the, don't know why, but it is the combination of the disarm functionality that I added, which is then allowing us to root the player. So now when I click it, I cannot attack and I also cannot move anymore. So the routing is now working properly again. And at the end, you can see I can finally move again and attack again. So that was also a small feature that I added to the game, which might be useful to you as well. Interesting that it's the combination which somehow allows us to root the player correctly in the dialogue. But whatever, so that was finally it. So again, that's the last part of this tutorial series. We covered now how to create the DSL for the dialogue. We covered a little bit the testing stuff. with the test-driven development. We added a dialog user interface, so that was a little bit of a repetition, I would say. So there was nothing, a lot of new stuff that you could learn. We added some coloring to our entities, that we can color them in tiled as well and support that so that they can have different colors. And we added some disarm functionality that entities cannot attack for a certain period of time. With that, that's it. I hope you enjoyed the series. Let me know in the comments if you liked it or not, or what I could do better in the future for my videos, if there is anything that can be improved. I know I'm almost perfect. Just kidding. And yeah, hope you have a great day. Enjoy your life and hear you in another video. Bye bye.